Hi there, my name is Christopher Lee. For my research project, I investigated a novel application of deep learning into the real-world field of remote sensing and infrastructure management. We've all seen the devastating toll improperly managed power infrastructure can have on both the economy and our everyday lives. Maintaining power line infrastructure is a monumental task, with millions of miles of lines in the US making routine field investigations of power lines possible. As a result, more and more utilities and co-ops are turning towards remote sensing technology to conduct large-scale surveys of their infrastructure. LiDAR is a sensor technology we use in remote sensing which emits pulses of light and measures the time it takes for those pulses to reflect on an object and come back to the sensor. When mounted on an aircraft or drone, LiDAR can be used to create a 3D map of the Earth's surface, called a point cloud. But simply having a point cloud isn't enough. After all, how do we know what each point is supposed to represent? Manually classifying point clouds is tedious, expensive, and requires specialized training. That's why in this study we propose to use deep learning to automatically and efficiently classify the power line objects from a point cloud. Deep learning has always been heavily geared towards images, with not a lot of research going into classifying point clouds. There's a good reason for that. Mathematically, an image is a much simpler object than a point cloud. An image represents regularized and ordered data, while a point cloud simply represents unordered points in 3D space, with much of that space being empty. That's why, instead of using regular convolutional operations like you would use on images, we propose using sparse convolutions, which can be used efficiently on sparse datasets like point clouds. We perform our experiments on networks constructed on these sparse convolutional operators. Another issue is that these power lines make up less than 1% of all points in a typical point cloud, which makes them much more difficult for the classifier to learn. So, to remedy this, we propose modifying the loss function of the classifier to be weighted towards the power line class by adding a weight term beta. We perform these experiments on a 120 km squared area dataset, which we split up into training and testing sets, and evaluate the performance of the trained model on the testing set. We compare the results from an unweighted loss function and a weighted loss function, and find that the weighted loss function improves the results significantly. Here are some sample results from the experiment, with successful classifications on the top row and erroneous classifications on the bottom. What we found is that these sparse convolutional neural networks can learn features that can properly classify power lines from unordered and irregular point cloud data, with over 99.8% accuracy. Additionally, we've found an effective method of dealing with severe class imbalance based on a weighted class entropy loss. Because our classifier can achieve similar results to a human expert, utility operators could remove thousands of man-hours of processing to more efficiently manage the infrastructure we rely on. Thank you.